project we're working on today is an overheating issue on a Volkswagen 4-cylinder. This would cover all 1.8 turbo models and 1.9 TDIs. What we experienced with this vehicle is no overheating at idle. But if you drive the vehicle 6 to 7 miles, the engine temperature will start to climb. On this vehicle, we knew that there was no stoppage in the radiator because it had recently had a coolant system flush, and we noticed that there were no water leaks or coolant leaks of any kind. Auxiliary fans were working correctly, but the vehicle just seems to, on the freeway or any kind of driving after 6 or 7 miles, the vehicle starts to overheat. So let's see what we did to diagnose this project and then turn around and do the repair. After running the car for a while, our suspicions were that we had some kind of circulation issue. So we removed most of the engine cover and stuff so we can actually see the motor. And what we did is we let the car warm up and we checked the upper radiator hose. Once the car was warm, upper radiator hose was warm, which indicated that the thermostat had opened. If the thermostat had not opened, we would have had a cold upper radiator hose. So the next thing to check would be, is the water pump actually circulating water? Well, in most situations, the water pump wouldn't be a suspect unless we had a leak of the water pump. But knowing that the design of the Volkswagen water pump, we decided to take the intake hose off of the vehicle. This is the lower radiator hose that fits up to about 1.25 inch fitting that goes just above the alternator. What we did with this hose is we took the hose off, connected another hose to it, and ran the hose to a bucket, and then started the engine once again. Now, if we would have had adequate circulation, we would have instantly gotten a rush of water coming out of the lower part of this radiator, which is this hose right here, because we would be circulating water from the pump through the engine block, out the thermostat, into the radiator. Bottom of the radiator would then dump into this bucket. We had zero circulation, or we had no water pressure coming out of this at all, which made us once again suspect the water pump. An interesting thing about the new design of water pumps these days for these cars is many of the manufacturers are deciding to use a plastic impeller. A plastic water pump impeller that on previous designs was made out of cast iron. The problem you have with a plastic impeller, the plastic is actually vulcanized to a little ring which then is pressed over the water pump shaft. And what seems to occur with these plastic water pump impellers is they will break loose off of the inner shaft, and that's exactly what happened to this water pump right here. Watch what happens. The actual impeller that's supposed to be pumping the water is just freewheeling. So that created a situation why the vehicle would overheat after only a few miles of driving. The impeller was turning, and probably a few weeks ago it was actually still frozen onto the shaft or pressed onto the shaft somewhat better than it is now. But what's occurred here is it's totally freewheeled now, so there's no water pump pressure at all anymore. So this vehicle went from a slight overheat to a gradual overheat till finally, probably in another few days, it would not have even gone a couple of blocks without running into the red. So this is a situation where when you purchase a new water pump, you'll want to get a water pump that has a metal impeller, an iron impeller, that is pressed onto the shaft and it can't break loose like this. In my opinion, it's just a design flaw. Now that we've discovered what the problem was, replacing the water pump is going to have to be the solution. We've already removed the pump out of this TDI, but let's take a look at what it's going to take to remove it. Typically, there's a plastic shroud that covers the timing belt and the timing gears. This gear right here is a fuel injection pump sprocket. This gear right here is the cam sprocket. The situation we've got to remember is that we have to keep the timing relationship of the cam, the injection pump, and the crankshaft the same. The crankshaft will stay put by just putting it at top dead center before you start the project. Here's the components we're going to replace with this project. Your base project is going to be replacing the water pump. What we're going to select is a water pump not like the factory one that has the plastic impeller that broke free on this TDI. We're going to replace it with a water pump that has a cast iron impeller, which is pressed on, and they've never come loose in my experience. So you're going to end up with a better water pump. At the same time, I recommend doing the timing belt, the tensioner pulley, and the idler pulley. These two pulleys here are typically spinning at a higher RPM than the engine, and the situation with these pulleys is they've got a permanently packed bearing that is packed with grease one time from the factory, which means they're going to spin their entire lifetime with the lubrication that's in that bearing. What you want to do is replace that at the same time that you're doing your belt. Now in turn, if you're doing a belt project, I would also recommend doing a water pump project, just in case. If you were to have a water pump leak, then you'll be doing these two projects in a staggered fashion. Do it once, you'll save some money on the labor. Now we're going to go over back to the TDI, and I'll show you how to make a tool that will allow you to lock the cam sprocket and the injection pump sprocket without buying an expensive factory tool. Here we are back at the vehicle, so you can see the cam sprocket locking tool that we devised to keep the cam sprocket and the injection pump sprocket in a locked stationary position for doing this project. If you watch one of my other videos, we've got the instructions on how to make this tool yourself. What it will basically do is it locks into two sprocket cogs on the injection pump and two sprocket cogs on the cam. We've also used a little whiteout here and marked where we're locked in. Once you tighten the bolt, those two sprockets are locked down for good. If you check out one of my other videos, you'll see exactly how to make this piece from small parts you can buy from the hardware store.